Hello class, in this video I'll be showing you how to create the area of a sector formula. Let's begin. So we're going to start off with the formula for the area of a circle, and that is pi r squared, where r is the radius of the circle. And what we're going to do is we're going to use pi r squared to find the area of the green region and the area of the red region. So to do that, notice that the area of the green sector is half of the circle. So the area of the green sector is 1/2 pi r squared. In the second example, the area of the sector is 1/4 of the circle. So the area is 1/4 pi r squared. In the third example, I don't know what ratio of the circle is colored in. So I'm going to go back to the first two examples to see if we can figure out another way of finding the area that doesn't require you to know that half of the circle was shaded or 1/4 of the circle was shaded. So let's look at some angles. Notice in the first example that is a 180-degree angle. So we can take this 1/2 and write it as the area is equal to 180 divided by 360 pi r squared. In the second example, notice that this angle is 90 degrees. So we can write 1/4 as the area is equal to 90 divided by 360 pi r squared. In the third case, notice we don't know what this angle is. So if we look at the patterns from the previous two examples, we can figure out the formula for the area of the blue shaded region by taking theta, dividing it by 360, and multiplying it by pi r squared. And notice that follows the pattern from the previous two examples. So in the first example, the angle was 180, so in the numerator it was 180. In the second example, the angle was 90, so in the numerator the angle is 90. And the denominator for both of the examples is 360. So the first area of a sector formula for when theta is in degrees is area is equal to theta divided by 360 pi r squared. So what happens when theta is in radians? Can we rewrite this formula so that theta is in radians? And the answer is yes. So remember that 1 degree is equal to 180 divided by pi. So the area is equal to theta divided by 360 times 1 degree times pi r squared. And I'm just going to highlight this orange. I'll highlight this orange. And I'm going to substitute 180 divided by pi in for 1 degree. So this is equal to theta divided by 360 times 180 divided by pi times pi r squared. And there are a few factors that divide. Notice the pi and the pi divide. And 180 divided by 360 is 1/2. So when theta is in radians, the area is equal to 1/2 theta r squared.